Okay, so our test is coming up, and I just want to make sure that we just do a recap of the mathematic techniques that you need to be ready to use in order to be successful in the APES test, both on the MCQ, but mostly on the FRQs. Okay, so it comes down basically to this. You're going to need to be able to do dimensional analysis. That's the main thing you need to be able to do in this course. Usually it takes small amounts and turn them into larger ones. So the thing you need to be able to do is calculate volumes, right? So you should know the area times height. We do it, okay? Uh, Using density to calculate mass or volume. So, and then the other one is to do take percentages and work with percentages to figure out final amounts or percent changes. All right, and also be able to convert from unit to unit is something you've got to be able to do quite a bit. So let's just jump into it. Okay, dimensional analysis is a way of converting between units. All right, now this is the main thing. So let's just take a few minutes to talk about this. So when we do dimensional analysis, basically we start with a given amount, and usually this is not a fractional amount. It could be, but usually it's not. That the main thing is you must include your units. If you don't include the units, especially with your first one, well, actually with all of them, you're lost. You're never going to get anywhere with this. So it's human to be lazy, but we can't be lazy with this, or we'll get nowhere. Plus, if we don't show this, we lose points on our FRQ. Now, we're just going to take our starting value and we're going to multiply it by a series of fractions. And the thing is, each of these fractions is equal to 1 because the top of the fraction equals the bottom of the fraction in every single case. 365 days is the same thing as 1 year. 24 hours is the same thing as 1 day, and so on. All right. And so the other thing is that whatever I start with here has to go in the denominator of the first fraction. And then remember, the top and the bottom have to be equivalent to each other. So then I have days here. So that means that has to go in the denominator. And then the top and the bottom have to equal each other. So whatever I have here has to go in the denominator. The top must equal the bottom. This has to go in the denominator until I finally get what I want on top. So let's just look at an example of this. Okay. So I have a gold deposit contains 2 grams of gold per 1,000 kilograms of ore. If the ore is extracted at a rate of 50 kilograms per hour, how much gold is extracted in 1 year? This is a very common kind of question they might ask you. Okay. So here's a trick to it. You want to start with a value that's not a fraction usually. In that case, 1 year. And I'm going to convert years into grams of gold. So I start off with 1 year. Now, man, I hate when that happens. I start with 1 year, and now the year has to go in the denominator. And I go, what could I turn years into? I could turn years into days. So I'm going to put 365 days up above. Now I need to get to hours. So I'm going to take days and I'm going to put days in the denominator and I can convert it to hours because I know that there's 24 hours in 1 day. Remember, these fractions, the top has to equal the bottom. Now that I have hours here, it must go down below. I have no choice. In fact, this is a great way on the MCQs. There's a number of MCQs that just give you a setup. And all you had to make sure, to get it right, you just have to make sure that this goes here, this goes here, this goes here. As long as that's true, it's going to be your answer. Okay, anyway, now I put hours down here. Now, what do I turn hours into? I see here I have 50 kilograms per hour. So that means that's basically an equivalency. So 50 kilograms is equivalent to 1 hour. So I can put kilograms up above. And as soon as I do, I had to get rid of it. So I put it down below. And now I say, okay, here's what else I know. I know that I can extract 2 kilograms of gold for every 1,000 kilograms of ore. So those are equivalent to each other. So I can link them this way. I can say 1,000 kilograms equals 2 grams of gold. And then what I do is once I get it set up, I multiply by all the top numbers. So 365 times 24 times 50 times 2 divided by all the bottom numbers, 1,000, and I get this value here. Okay, now, so one trick is to look at it and see what units you should end up with. And make sure that at the end of it, that's what you end up with, those kind of units. The other thing you want to do is if you're told that something equals something, you always write that as a fraction. Okay, so let's look at this example. So remember, if I say there's this many of these and this much of that, they're equal to each other. I can write it as a fraction. So look at this. I have 800 zooplankton in every milliliter of lake water. That means they're equal to each other. I can write them as a fraction. Every zooplankton eats 50 milligrams of algae. In other words, 1 plankton equals 50 milligrams of algae. Again, I can write that as a fraction. How much algae is eaten in a 200-liter puddle in a day or a week? Okay, so I start off with a unit. I start off in this case with how much water I have. I have 200 liters of water, and I want to convert that into the amount of algae that's getting eaten. So I'm going to take 200 liters. I'm going to put liter in the denominator. Then what can I turn it into? Milliliters. Why? Because I have milliliters here. So, and you have to know that 1,000 milliliters equals a liter. You have to know that 1,000 millimeters equals a meter. You need to know that 100 centimeters equals a meter. You need to know those basic conversions that I talked about the other day. So now I have millimeters. I put them in the denominator. What can I turn milliliters into? I was told 800 zooplankton in every milliliter, so I can write that as a fraction. If milliliters is here, I can write 800 plankton up above. I don't want plankton, so I put them down below. What could I turn plankton into? Well, I'm told that each zooplankton eats 50 milligrams per day. So I can say one plankton equals 50 milligrams per day. That's a unit, okay? And then what happens is liter cancels out, milliliters cancels out, planktons cancel out, and I'm left with milligrams per day. And now when I put in my calculator, what I got was 8E9. I don't know about your calculator. That's what mine said. If yours says 8E9, you could write that and hope for the best. Or you could say what that really means is 8 times 10 to the ninth. If it said 8E negative 7, I'd say 8 times 10 to the negative 7, okay? And I have milligrams per day. Now, how do I turn that into a week? Well, I'm just going to take this value here and start with that. I'm going to start with this many milligrams per day. And a lot of times I don't want to start with a fraction. In this case, I have to. Now, watch what I have to do here. I want to turn this from milligrams per day to milligrams per week. So often what you're doing is you're taking whatever in the numerator and putting in the denominator. But in this case, we're going to do the opposite because I want milligrams to be in the numerator when I'm done. I want to say how many milligrams per week. What I don't want is to have days in the denominator. Well, the way you get something out of the denominator is you put it in the numerator and say, well, if days are in the numerator, what could I put in the denominator? And the answer is weeks. I know that there are 7 days in 1 week. And therefore, the days cancels out, and I end up with milligrams per week. And I just multiply this number by the top number, divide by the bottom, and I get that. Be prepared to do both of these types of techniques. So let's just look at an example that I pulled from one of the FRQs on energy. Okay, so basically we have all this verbiage here, and ultimately the first question was, assuming that the existing power plant can operate at full capacity for 8,000 hours per year, how many kilowatt hours of electricity are produced? Now, here's one thing I noticed a lot of you got confused when we did energy. I pointed out to you that a watt is basically a measure of power, and that one watt equals 1 joule of energy transferred per second. However, in most of the cases on this test, they're not going to ask you to talk about joules. They're going to talk about kilowatt hours instead. So don't think of power in this case as something that you need to write as a fraction, as joules per second. It's not necessary. So look what we're going to do. It says I'm going to take my power plant. It produces 12 megawatts. And I want to see how many kilowatt hours that would be in a year. So I start with 12 megawatts. Now, the thing is, I want kilowatt hours. I don't want megawatt hours. So what I'm going to do is I'm going to take kilowatts. Now, megawatts, sorry. And now it has to go into the denominator. Now, I've learned that mega means million. So I know that 1 megawatt equals 1 million watts. If you know how many kilowatts that is, great, go for it. But if you don't, you just remember, okay, I know mega means a million goes up here. I didn't want watts, I want kilowatts. Since I don't want watts, I put watts down below. I put kilowatts up above. And what I know is 1 kilowatt is the same thing as 1,000 watts. So I multiply this times the top, divide it by the bottom, and I get 12,000 kilowatts. Now I want to figure out how many kilowatt hours is produced in 1 year at 8,000 hours per year. So I take my number of kilowatts right here, and I multiply it by 8,000 hours per year. And you'll notice that what happens is it all comes together, give me kilowatt hours per year, which is what I was asked to come up with. And I end up with 96 million kilowatt hours per year. Okay, let's talk about volumes. Okay, so to calculate a volume, I think we all know that volume equals length times width times height, or really what you should think of is area times height, because they'll often give you an area. Okay, and then you always want to make sure that the units match. They like to trick you this way, so always make sure if I've got meters and I've got millimeters, that ain't gonna work. I'm gonna turn one into the other in order to work with it. Okay, so look at a classic example here. Okay, it rains at a rate of 2 centimeters per hour for 6 hours on a 5,000 square meter parking lot. Whoop, whoop, whoop. The units don't line up, okay? I've got square meters and I've got centimeters. Okay, so I'm going to fix this, okay? But anyway, let's keep going. How many liters of water is discharged by the parking lot? And then I'm told 1 cubic meter equals 1,000 liters. Okay, that's not something you have to memorize. So first thing I'm going to do is I'm going to say, well, look, if it rains for 6 hours at 2 centimeters per hour, how much rain came down. Well, that would be 6 times 2, that'd be 12 centimeters. So I say I have 12 centimeters of rain came down, and I want to turn that into meters so I can use it with this one here. I cannot multiply centimeters by square meters. It just doesn't work. So I convert centimeters and I say, look, if centimeters is here, centimeters has to go here. I can put meters up here. 100 centimeters is equal to 1 meter. You need to memorize that. And when I multiply them, I get 0.12 meters. Now I can calculate a volume. So now I can say an area times the height gives me 600 square meters of rain that came down. Then I was asked to figure out how many liters of water. So I'm going to take my cubic meters and say, okay, 600 cubic meters. I don't want cubic meters, so I put cubic meters in the denominator. I'm going to put liters up above. They're linked together with an equivalency, so I can put them there. And then I get my answer by multiplying this by the top and dividing by the bottom. Let's start working with density values. So density is basically a conversion, right? It says this many grams equals a milliliter, okay, or a cubic centimeter, okay? So just think of it as just a conversion factor between mass and volume, all right? So let's look at what I've got here. I got a 400 square meter tract of land, has a coal seam that's located at a depth of 20 meters. The overburden has a density of 3 grams per cubic centimeter. How many kilograms of rock must be removed? And by the way, we're told 1 cubic meter equals 1,000,000 cubic centimeters. Okay, you might think, what do I do? Well, the first thing I do is you got to figure out what's the volume we're talking about. What volume of rock has to be removed? You need to know the overburden is the rock that needs to be removed. So in this case, my units actually match. I have meters and meters, so I just multiply area times height. I get 8,000 cubic meters. Okay. Now what I'm going to do is I'm going to convert those 8,000 cubic meters into kilograms. So I say 8,000 cubic meters. Where does this have to go? It must go in the denominator. What can I turn cubic meters into? I'm told I can turn cubic meters into cubic centimeters. Okay, so 1,000,000 cubic centimeters equals 1 cubic meter. Now, if I have cubic centimeters here, it has to go down below, and that's where the density comes in. When I'm given this, what that really means is 3 grams is equivalent to 1 cubic centimeter. So 1 cubic centimeter equals 3 grams. I don't want grams, so they go into the denominator, and I'm asked to find kilograms. So you have to know that 1,000 grams equals a kilogram. And once I have this set up, I multiply all the top numbers, divide by all the bottom numbers. I get 24 million kilograms. Now let's start by using percentages. Okay, so sometimes what we have to do, the first thing you need to know is you're given a percentage, but it's really hard to use a percent in math, right? So what you really need to do is convert it to a decimal, right? So if we're told, let's just say if I ask to find what is 70% of 500, I just say 500 times 0.7. I think you know that, but you just need to remember that when you're doing this, okay? Be careful, because if I've got a single digit percentage, it's really easy to screw that one up. So if I say, well, 3% of 500, make sure you don't multiply by 0.3, you have to multiply by 0.03, because essentially you're dividing this by 100, right? 70 divided by 100 is 0.7. 3 divided by 100 is 0.03. Okay? Now, so watch out for that. Okay, so that's how we use these. Okay, so they might ask you to solve a problem like this. 4,000 liters of rain lands on a given area of land. 30% of the rain infiltrates the soil. 8%, 8% of the runoff evaporates before it reaches the nearest stream. 60% of the water that infiltrates adheres to mineral particles in the soil. Okay, so how much of the rainwater ends up as groundwater? So the first thing I do is I say I have 4,000 liters that came down, and of that, if 30% of it infiltrated. So I say 30% would be 4,000 times 0.3, that gives me 1,200 liters. But of that, what I'm told is 60% of it is going to adhere to mineral particles. Well, if that's the case, what did not adhere? So if 60% adhered, then 40% did not. So therefore, I'm going to multiply this value here by 0.4, and that's going to give me my value. All right, let's try another one here. Okay, so the same problem, except in this case, I want to know how much rainwater ended up evaporating. Okay, well, what I know is that 30% of it infiltrated. That means 70% of it did not infiltrate. So I take the starting value and I multiply it by 0.7, because 70% of it did not infiltrate. So this is how much water was left at the surface and didn't go into the soil. And I'm told of this water, 8% of it evaporates before it reaches near a stream. So that means I have to multiply that by 0.08, and this is how much water evaporated. Last thing I'm going to talk about is percent change. We've done this a bit this year, but let's try it again. Okay, so if you're asked to find a percent change or percent increase, percent decrease, here's what you do. You have to remember percent change is equal to the ending value minus the starting value divided by the starting value times 100%. Got to know that one. All right. All right. So let's say the population of parrots on an island was 22 in 2010, and it was 36 in 2020. What was the percent change in population? So the percent change is just going to be the final value or the ending value minus the beginning value divided by the beginning value times 100% gives us 63.6% increase. But they might ask it to you this way instead. All right. Population of the parrots was 36 in 2020, but a disease came along and it caused a 44% decline in the parrot population by 2021. So what was the parrot population after that 44% decline? So I'm taking that same equation and I'm just going to substitute into it. Okay, so I had to remember a decline means negative growth, right? Negative percent change. So I'm going to take that 44 and I'm going to call it negative 44 because it went down. Okay, ending population is what I want to know. I know the starting population was 36, so I just put it there. All right, and now let's just do basic algebra. Okay, so first thing I do is going to get rid of this 100 times 100. I'm going to divide by 100%. 44% divided by 100% gives me negative 0.44. That equals ending population minus 36 over 36. Well, next thing I'm going to do is I'm going to multiply both sides by 36 to clear this out of the denominator. That gives me negative 15.84 is equal to the ending population minus 36. So if I wanted the ending population, I have to add 36 to both sides. So I'm going to add 36 to both sides. This goes away, and this becomes 20.6. I doubt if I have 16% of a parrot, so I'm just going to round this and say there's probably 20 parrots. Thanks for watching. I hope this helps. You guys are ready for this test. You are, okay? Please practice.